Mr. Brescher here, reporting for duty all the way from Ireland, Indiana. All right, and today we're going to be focusing on learning how to construct a line graph and how to interpret data in a line graph to answer statistical questions. Some of the standards that we're really kind of homing in on is 6.2, which is select, create, and interpret graphical representations of numerical data, and 6.3 to formulate statistical questions, collect and organize data, and display and interpret the data with graphical representations. So let's move on. Here we go. First of all, we need to know a little bit about a line graph. What parts make up a line graph? First of all, we have the title here, and that's where you'll find what the line graph is displaying, the information that it's giving. Okay. The other thing, we obviously need to know when we would use a line graph. And the time that we would want to use a line graph is any time that we are wanting to show a change over time, or a trend, or a change in numbers over time. Usually the vertical axis over here will show the actual change in the values, and then if we look at the horizontal axis, it will actually show the periods of time, like months of the year, or it could be times throughout the day. It could also be years. Okay, in order to plot the points, we would want to find the time that corresponds to a specific number or value, and we would mark that point where it intersects. And then at the end, we connect the points with lines to make this graph. Can anybody tell me what the trend of this graph is, or what is actually happening? Yes, it helps us to see that whatever it's displaying is going up over time. It has a few areas where it falls down, here and here, but mainly it's going up. Let's move on and look at some real-world examples. Here we have an example. Take out your notebook and let's go ahead and make our own line graph. The first thing that we need to do is decide what our title is going to be for this particular line graph. Okay, so when we look at this, the title, it looks like the chart we're looking at here says tons of ice sold. Okay, so we want to go ahead and label that up at the top where we would normally label a title. Next, we want to look at our actual data. We can see that the months are being displayed, so that is the time. Does anyone know what axis that would go on? Would it be the vertical or the horizontal axis? Excellent. It would be the horizontal axis. So we're going to put all those dates down here. Go ahead and do it on your own. And then we're going to look at the amount or the numbers over here. And remember, this is in tons of ice that are sold. One way to decide what kind of interval to use over here when we're putting in our actual values, I usually try to find the highest number, and then I'll divide that by 10. And that'll tell me about what interval I want. Here I see July is the highest with 98 tons of ice sold, and if I divide about 100 divided by 10, my interval would be 10. So let's go ahead and label this side by tens. And also label the subject or the title, since it's displaying the tons of ice sold. The next thing we want to do is find each number that corresponds with a date, and you want to plot those points. Go ahead and do so on your own. Pause the screen, and when you return, we'll go over what you should have come up with. Okay, we're back and ready to look at what you should have come up with. When you're plotting the points, they should have been plotted similar to this, and we notice here that it seems to increase quite rapidly all the way till about July, and then it starts tapering off. Does anybody think they know why maybe that this graph would increase so rapidly and then go down? Yes, absolutely. The ice that's being sold in January, you might not need as much ice. Or it's not melting as quickly, depending on where you live. Therefore, ice sales are pretty low. And as we increase to July, when it's a warmer season, at least in the northern hemisphere, then the ice sales really increase rapidly, and they start to fall off again as the temperature kind of declines. So let's move on and look at another graph, and try to do this one again on your own. This graph, what should be the first step that we do when we're making this graph? Excellent. We want to put our title up top. Okay, so go ahead and put your title up top. And again, we're referring to this kind of chart over here. The next thing, we can label our horizontal axis. Go ahead and do so yourself. Again, if you have to, pause the screen, and then we'll go over it. And there we have our horizontal axis. That is the time. Remember, we're showing a change over time. Now we need to look at some of the amounts in here and see what interval we want to have on the vertical axis of this chart. I like to, again, find the highest number, and it's $1,300 raised. And then we want to take that amount divided by 10. If I divide by 10, I get 130. It's kind of difficult to work with 130, so I'm just going to go ahead and say I'm going to make the interval 150. Go ahead and do so on your own. It should look like this. Make sure again that you're labeling over here what these numbers stand for. The money raised in dollars for cancer by JMS, or by your school maybe. Okay, the next thing that we want to do is go ahead and find those values in the chart and mark a dot next to the corresponding numbers in the graph. Go ahead and do so. Pause the screen, and when you come back, we will have our dots marked as well. Okay, so how does yours look? Does it look similar to this? Excellent. The next thing that we want to do, now we got to make sense out of this. And the best way to make sense out of it is to connect the dots, essentially. We're going to connect the dots. Go ahead and do so on your own, and pause the screen. When you come back, we will have these dots connected. And here we are. So how did you do? Now let's think of a couple statistical questions. I'll think of a couple and ask them for you. And then you can think of a couple and ask to your neighbor and see what they come up with for the answer. My question would be, when was the most rapid decline in the amount of money raised? In what year did it decline the most? Excellent, 2002. We can see that it declined very rapidly from 2001 to 2002. Now, normally you can try and think of or speculate on why that might have happened. But these numbers were just kind of put together randomly. Therefore, we may not have a specific reason. Overall, we might look at some other things, like when was the most rapid increase? And we can tell that it would either be from 2005 to 2006 or from 2008 to 2009. You'd have to look at the data more specifically. It looks like actually 2002 to 2003 it increased quite rapidly as well. Those were 3 years that must have had very good years as far as increasing from the previous year. Think of a couple statistical questions that you can ask for your neighbor. And go ahead, pause the screen, ask those questions, and see if they can answer them. Okay, we're ready to move on. Finally, we've got which of the following sets of data would you most likely use a line graph to display? Check all that apply. Remember that it's very important that we're looking for the type of data that line graphs display. So what type of data do they display? Excellent. Some type of change over time. Go ahead and check all that apply. Okay, let's see what you came up with. If you checked these three, you are correct. Okay, they all display over data over a period of time. Here we're talking about German American Bank from 2006 to present. That is a period of time. This one is over the last 500 years, average global temperatures, maybe to check on climate change or global warming. And this final one to see student growth over the process of the school year. Or you could even do it over many years from like first grade all the way to 12th grade. This would be a great way to display data using a line graph. Does anyone know what you would use to illustrate student test scores for a class of 30 students? Excellent. You would likely use a stem and leaf plot. It's very easy for large sets of data to display that data. Okay, and what about one that would compare sizes of household dogs? Okay, excellent. A bar graph is a great way to compare sizes. So that would be great on that one, a bar graph. I got this B over here. Go Baltimore Orioles. That's my shout out for today. Hope you all learned something. See ya.